Lesson 7: Understanding Relations and Functions. This is another exciting lesson. Here comes Grace, who will be your guide.
Hey everyone! Get ready for something new and exciting. We are diving into relations and functions. These are building blocks for the rest of our algebra journey. Today, we'll learn some new math words. These words are relation, domain, range, and function. Don't worry. The math we'll do is similar to what you already know. We'll even revisit graphing points to get ready for what's ahead. A fun twist is that some equations will not have just one answer. Sometimes, there will be no answer at all, and other times, there will be endless possibilities. Lastly, we'll learn to tell the difference between a relation and a function. Every function is a relation, but not every relation is a function. Ready to explore? Let's get started. Imagine you're organizing your favorite outfits. You have a list of shirts and a list of pants. When you pair a shirt with pants, that's kind of like a relation in math. A relation is just a way to match up two things. We call these pairs ordered pairs. For example, blue shirt, jeans is an ordered pair. It shows a connection between two items. We can show these connections in different ways, like making a list, plotting points on a graph, or using a diagram. No matter how we show it, the information is the same. The domain is like the list of all the possible inputs in a relation. It is always the x variable, which is often called the input. Imagine you have a vending machine. The domain would be all the different amounts of money you can put in. The range is like the list of all the possible outputs in a relation. Think of it as all the possible snacks you could get from a vending machine. For example, like my favorite snack, chips. A function is like a reliable machine. You put something in, the input, and it always gives you the same thing back, the output. That's why math is so useful, it's predictable. In the near future, you will need the domain and range to write equations of functions. Remember this important rule: if an x value, input, appears more than once, it must be paired with the same y value, output, to be a function. Here's a common trick. Sometimes, a list of ordered pairs will have the same x value twice. Don't be fooled. If the y values are the same for that repeating x, it's still a function. But if the y values are different, it's not a function. Let's try an example. Pause the video and think about it before I give you the answer. Example 1 with the points 1, 2 and 1, 3 is not a function because the input 1 has two different outputs, 2 and 3. Example 2 with the points 4, 5 and 4, 5 is a function, even though the input 4 appears twice. It's paired with the same output, 5, each time. Here is a real-life example of a function. What is the relationship and outcome for Chuck, who earns $12 an hour and works 10 hours? Think about it for a moment. What is the input? What is the output? Can you write this as an equation? The following slide will answer these questions, but pause the video and think about it first. Let's say Chuck gets paid $12 an hour. Although the number of hours he works will change each week, his hourly rate will stay the same. In math, we use letters, or variables, to represent things that can change. For example, we could use h to represent the number of hours Chuck works. His total pay, let's call it P, would equal his hourly rate $12 multiplied by the number of hours he works, h. As an equation, that looks like P is equal to $12 times h. When graphing ordered pairs, I like to imagine a treasure map. An ordered pair is like a set of directions. It tells you where to find your treasure on the map. The first number in the pair tells you how far to move, left or right. This is the x-coordinate. The second number tells you how far to move up or down. This is the y-coordinate. Let's say your treasure is at 3, 2. You'd start at the starting point, like the center of the map, move 3 steps to the right, then 2 steps up. There's your treasure. We will see this demonstrated on the next slide. Do you remember where to start? That's right. You begin at the origin, which is 0, 0, the center of the graph where the x and y axes intersect. Next you move to the right 3 units. Do you remember what to do next? That's right. You move 2 units or spaces up. Then, you place a dot at 3 along the x-axis, and 2 along the y-axis. This is where you will find the treasure. We've plotted single points before, but now we'll place multiple points on the same graph. You'll be given a list of ordered pairs to plot. After plotting, we'll explore what these points tell us together. Do you remember the new word for ordered pairs? I will give you a moment to think about it. That's right. The new word for ordered pairs is relations. During the rest of this course, relation and ordered pairs will be used interchangeably. Graph the following points on the grid. You can find the grid on your worksheet. Pause the video now. The solution will be on the next slide. Here are the 3 points. Did you plot them correctly? If not, double-check these steps. First, did you start at the origin? Second, did you move left or right based on the x-coordinate? Finally, did you move up or down based on the y-coordinate? Let's dive deeper into relations. We'll be asking 3 main questions about our sets of ordered pairs. What numbers are used as inputs or x-values? This is called the domain. What numbers are used as outputs or y-values? This is called the range. Does each input have precisely one output? If so, it's a function. Let's explore these questions together. Let's talk about the domain. The domain is just a fancy way to say all the x-values. Imagine you're listing all the different x numbers you see in your ordered pairs. We use little numbers below the x, like x1, x2, x3, to help keep track of which x we are talking about. These little numbers are called subscripts. So, x1 is the x in the first pair, x2 is the x in the second pair, and so on. In this example, our domain would be all the different x values we found. Can you list all the x coordinates of this relation? The domain of this relation is 1, 3 and 5. Note how these are written. There is a curly bracket, and each number is separated by a comma. This is called a set. Sometimes it is written with the variable inside the curly brackets. For this class, we use set without the variable. Let's talk about the range. The range is just another way to say all the y coordinates. Imagine you're listing all the different y numbers you see in your ordered pairs. Like we did with the domain and the x values, we use little numbers below the y, like y1, y2, y3, to help keep track of which x we are talking about. Remember, these little numbers are called subscripts. So, y1 is the y in the first pair, y2 is the y in the second pair, and so on. In this example, our range would be all the y values listed in the ordered pairs. Can you list all the y coordinates of this relation? Pause the video while you work on this. Sometimes, the domain and range numbers match, and sometimes they don't. It all depends on the pairs in our relation. Let's explore this more as we look at different examples. So, don't read anything into this. This is a common question that students are asked, but they are never given any real instruction on how to answer. In a math class, you want to look for patterns. Look at this before we proceed. See if you notice a pattern with these points. Pause the video and think before proceeding. The apparent pattern is each point goes up from the left to the right. Another thing you could mention is how far up and over the points are. You may notice a point may be placed at x is equal to 2 and y is equal to 1, and x is equal to 4, and y is equal to 4. This would make a nice straight line. You will be asked if points make a straight line in your independent practice. Think about this as you answer that question. Here are 3 different points. Your job is to plot them before proceeding to the next slide. Once again, this comes from Independent Practice Download. Pause the video while you plot the points. Here are the 3 points. Did you plot them correctly? If not, double-check these steps. First, did you start at the origin? Second, did you move left or right based on the x-coordinate? Finally, did you move up or down based on the y-coordinate? Let's figure out the domain and range. Remember, the domain is all the x values, and the range is all the y values. Look carefully at your ordered pairs and make a list of each. Pause the video as you complete your work. The domain for this relation is -4, -2, and 0. Listing the numbers in the domain and range in ascending order is standard practice. This makes it easier to see the spread of the values and compare different sets. Some teachers count off, and some don't. Always do what the person grading wants you to do. In this class, either will be fine, but it is highly recommended to follow standard practice. Especially if you plan on taking higher math level courses. Now, let's look at the range. This set's range is -2, 0, and 3. Be sure to comment if you have any questions. Take a closer look at the points you plotted. Is there a pattern? Do the points form a straight line, an out-of-place point, or something else? What do you notice about the relationship between the x and y values? Pause the video, and on the next slide, I will share what I saw. I noticed that any 2 of the 3 lines would form a straight line. Depending on how you look, there is one point that doesn't belong. In math, we call that an outlier. Soon, you will write the equation of a line given 2 points. To do this requires you to find the slope. So, if you wanted, you could calculate the slope between any 2 points, but not all 3 points. The key to answering the what you noticed questions is stating something mathematical. If you do that, there is no wrong answer. The purpose is to improve your math intuition. Let's recap this lesson. We discovered that equations can have one answer, no answers, or even endless possibilities. We also met some new math friends, relations, domain, and range. Let's recap this lesson. We discovered that equations can have one answer, no answers, or even endless possibilities. We also met some new math friends, relations, domain, and range. Remember, a relation is just pairs of numbers like connections.